Hey, what is up? Ace out here from Instaproofs, and in this video, I'm going to talk about the Pythagorean Theorem. Now, the Pythagorean Theorem comes up a lot in cases where we need to find the distance between 2 points, say in the xy plane, or in the xyz space, or if we need to find the length of the third side of a triangle, given the length of the other two sides. But where does this Pythagorean Theorem come from? And if you were ever asked to derive it, could you? Well, in this video, I will do exactly that. So given a right triangle with leg sides A and B, and hypotenuse side C, we want to derive the Pythagorean theorem, which is a squared plus b squared equals c squared, given our right triangle. And in this video, I am going to do it in two ways. So for our first proof, we draw out a square. And now we inscribe a smaller square inside it. And by symmetry, you can see that this square is inclined at an angle theta from the outer square. By the way, it can be mathematically proven that all the inclination angles of this inscribed square are the same value theta. But for the sake of simplicity, I'm just going to use logic and say, by symmetry, that they're all the same value theta. And second, since the outer square is well as square, all of its corners are 90 degrees. And by deducing these geometric constraints, we can see that we have four congruent right triangles. For each triangle, we will label the large leg side A, the small leg side B, and the hypotenuse side C for the sake of our proof. And now that we can see that we have our right triangle with sides A, B, and C, we have all the tools ready to start our derivation process. So the area of the outer square, which we will denote by a large square symbol, is equal to the length of each of its sides squared. But the length of each of its sides is just the sum of a large leg side A of one of the triangles and a small leg side B of the other triangle. So we get the quantity A plus B squared. Now the area of the inner square, which we will denote by a small square symbol, is the square of the length of each of its sides. But the length of each of its sides is c, so we get c squared. Now lastly, the area of each triangle, which we will denote by a triangle symbol, is simply just 1/2 times each of its leg side. But one of its leg side is A, while the other is B, so we get 1/2 times A times B. And now we can see that the area of the outer square is equal to 4 times the area of each triangle plus the area of the inner square. And by plugging in our respective area equations, we get the quantity A plus B squared equal to 4 times 1/2 times A times B plus C squared. Foiling the left side, we get A squared plus 2AB plus B squared. And seeing that 4 over 2 simplifies to 2, on the right side, we get 2AB plus C squared. Subtracting 2AB from both sides, we then get our Pythagorean theorem, A squared plus B squared equals C squared. Now for our second proof, we will draw out a triangle with small angle theta and sides A, B, and hypotenuse C. Now we are going to take the same triangle and we are going to rotate it 90 degrees clockwise about the right angle corner and scale it down so that the side that was supposed to be A is now B for this triangle, and the side that was supposed to be B, we will denote it by a new letter D, and the hypotenuse is now F. And since this smaller triangle is just a bigger triangle scaled down and rotated 90 degrees, the top angle is now theta. And for each triangle, the larger acute angle is just equal to 90 minus theta, because all the angles of a triangle have to equal to 180. But since the top angle for the largest triangle, which is the sum of both triangles, is just the sum of the top angles of each individual triangle, we get the sum of 90 minus theta plus theta. But 90 minus theta plus theta is 90. So the top angle is 90 degrees for our largest triangle. And now we take the trig identity tangent of theta. And by using this identity for our large triangle or our left triangle, we see the tangent is opposite over adjacent, so it's B over A for this triangle. While for our small triangle, using opposite over adjacent, we get D over B. Now similarly, using the trig identity cosine theta, equal adjacent over hypotenuse. For our large triangle, adjacent over hypotenuse is A over C, while for our largest triangle, adjacent over hypotenuse is C over A plus D. So now we are going to take the relationship B over A equal to D over B from our tangent theta relationship, and we want to multiply A and multiply B on each side, and we get AD equals B squared. Similarly, we want to separate the relationship A over C equal C over A plus D from the cosine theta relationship. Multiplying both of the denominators from each side, we get A times the quantity A plus D equal to C squared. Distributing the A, we get A squared plus AD equals C squared, and using the equation AD equals B squared, we arrive at our Pythagorean theorem of A squared plus B squared equals C squared. So yeah, there you have it. The Pythagorean theorem proven in 2 different ways. I'm sure there are many other ways. And if you ever get bored, you can always try those different ways. But here, I just want to keep it as simple as possible. And if you like what you learn, make sure to hit the like button as well as the subscribe button. Until next time, thanks for watching.